Welcome to this lesson on control flow. Here, you'll learn how to add more functionality to your code by being able to use conditional statements and loops. You'll learn how to implement decision-making with if statements, repeat code with for and while loops, exit or skip loops with break and continue, use helpful built-in functions like zip and enumerate, and combine some of these concepts in concise list comprehensions. With these tools, you'll be able to bring together the data types and operators you learned from the previous lesson in more complex and creative ways. Let's get started. Now you know how to execute a block of code if a condition is true. But what if you have a different block of code that you want to execute when that condition is false? You can use the else keyword to do so. Consider this code, which prints a message indicating whether an integer n is even or odd. If n is even, this line is run. Otherwise, this line is run. Code indented under the else is what happens when this condition evaluates to false. The else keyword is always followed by a colon and doesn't need a Boolean expression. So, if we set n to be 4, like this, the if statement here would evaluate to true, and we would print the following string. Alternatively, if we set n to be 15, this condition would evaluate to false, so we would skip this block and execute the code under the else. If you have more than 2 possible cases, you can also use elif, short for else if, to deal with this situation. This saves the multiple indentation that would be needed if we used else and then another if statement inside the else block. Like if, an elif statement always requires a conditional expression. For example, let's say we wanted to print what to do with the garden based on the current season. If we set season equal to spring, like this, then we can see that plant the garden is printed, as this first condition evaluates to true. Alternatively, if we set season to winter, then each of these conditions will evaluate to false until we hit this condition, which will evaluate as true, and print stay indoors. Notice here we are using double equal sign again. Remember, a single equal sign is for assignment, like we did here when we were setting a season as a particular string. 2 equal sign is for evaluation, where we are evaluating a condition as true or false. We've been running code that simply executes every line one by one from the top down. Many times, however, we want to run code only if a particular condition holds. To demonstrate this concept, let's take a look at this billing system for a pay-as-you-go mobile phone. Say a customer has a credit balance for their phone, which they can use for calls and messages. The customer can then set up a link to their bank account so that if their phone credit balance goes below a threshold amount, in this case $5, then $10 more of credit are added and their bank balance is billed. Here is a simple way of representing this billing system in code. If the phone balance is below 5, add 10 to phone balance and subtract 10 from bank balance. This is an example of an if statement. An if statement is a conditional statement that runs or skips code based on whether a condition is true or false. In an if statement, the if keyword is followed by the condition to be checked, in this case phone balance less than 5, and then a colon. The condition is specified in a Boolean expression that evaluates to either true or false. After this line is an indented block of code to be executed if the condition is true. So in this case, these lines will only execute if it is true that phone balance is less than 5. If phone balance is 3, this condition evaluates to true, and these indented lines of code are executed. You can observe these changes in the output. If phone balance is 8, however, this condition evaluates to false, and these lines are not executed. As you see in the output, there were no changes to phone or bank balance, which is what we expect to happen since the condition in this if statement was false. As you have just seen, indentation is important. It's how we tell Python what code is in the body of an if statement and what code is outside of it. Indentation doesn't just matter in if statements. Soon, you will see it used in other contexts. Some other languages use braces to show where blocks of code begin and end. In Python, we use indentation to enclose blocks of code. This indentation conventionally comes in multiples of 4 spaces. It's important to be strict about following this convention because changing the indentation can completely change the meaning of the code. If you are working on a team of Python programmers, it's important that everyone follows the same indentation convention. All of the if and elif statements we've seen so far have been followed by a single Boolean expression that checks only one condition. However, more complicated Boolean expressions can be useful as well. If the condition is working with a numerical variable, you might want to check whether a value lies in a certain range, or even do some calculation in order to make a comparison. Notice this condition uses logic and algebra and will still run correctly in Python. Storing values for height and weight, we can quickly print the result for any individual. Some situations may call for logical operators. If it's rainy and sunny, I might look for a rainbow. Notice that the if statement here requires that both of these individual variables hold true to evaluate as true. If either is false, then this line will evaluate as false, and our print statement will not run. Let's say I want to send a promotional email to a customer if they have not requested to be taken off the email list, and they're in a location where they'll be able to redeem the offer. For really complicated conditions, you might need to combine some ands, ors, and nots together. Use parentheses if you need to make the combinations clear. However simple or complex, the entire line in an if statement must be a Boolean expression that evaluates to either true or false. And it is this value that decides whether the indented block in an if statement executes or not. We'll go over some good and bad examples of Boolean expressions used in if statements. While true is a valid Boolean expression, it's not exactly useful as a condition, as it always evaluates to true. So the indented code will always get run. Similarly, if false is not a condition you should run either. The condition in the if statement would never occur. In this example, is cold or not is cold will always evaluate to true. If it is cold, then is cold will be true. If it is not cold, then not is cold will be true. This has no use as a condition because the indented code will always get run. This code is valid in Python, but it is not a Boolean expression, although it reads like one. The reason is that the expression to the right of the or is not a Boolean expression. It's a string. Later, we'll discuss what happens when you use a non-Boolean type object in place of Booleans. It takes a few more characters, but this is now unambiguously a Boolean expression. The expressions on both sides of the logical operator OR are each checking something. This is a valid condition, but we could express it more briefly and clearly. Is cold is a Boolean expression on its own right, so we can make the code more readable by using the variable itself instead. If you want to check whether a Boolean is false, you can use the not operator. Let's summarize the lessons from these examples. True and false are both Booleans, but it doesn't make sense to use if true or if false. Logical operators and, or, and not have specific meanings that aren't quite the same as their meanings in plain English. Make sure your Boolean expressions are being evaluated the way you expect them to. Don't compare a variable that is a Boolean with equals true or equals false. This comparison isn't necessary since the variable itself is a Boolean expression. So far, the conditions we've used were Boolean expressions that evaluate to a Boolean object. either true or false. If we put some other object that is not a Boolean in the if statement, Python will check for its truth value and use that to decide whether or not to run the indented code. Here, the condition is an integer variable and evaluates to true. The Python documentation lists all the objects that are considered false in this situation. Anything that isn't listed as having a truth value false will evaluate as true. In this code, errors has the truth value true because it's a non-zero number, so the error message is printed. This is a nice way of writing a succinct if statement. Similarly, in this example you saw earlier, the string in the second part of this condition will evaluate to true. So this statement will always evaluate to true regardless of what value is stored in weather. Alternatively, this will evaluate to true if weather is the string snow, and will evaluate to false if weather is any other string. However, these types of conditions aren't really common knowledge and are not common in practice. Now that you've learned about conditional statements, let's move on to loops, which allow us to repeat blocks of code. Python has two kinds, for loops and while loops. Let's first take a look at the for loop, which we can use to iterate over an iterable. An iterable is an object that can return one of its elements at a time. This can include sequence types, such as strings, lists, and tuples, as well as non-sequence types, such as dictionaries and files. You can define objects with an iter method to allow them to be used as an iterable, which you can find more information on in the notes below. Consider this for loop that iterates through a list of cities, capitalizes each one, and prints it. The for keyword signals that this is a for loop. Cities is the iterable, and city is the loop's iteration variable. That is, the variable that represents the element in the iterable that the loop is currently processing. So in the first iteration, city would be New York City. In the second iteration, it would be Mountain View, and so on. We can use the city variable to refer to an element within the indented body of a for loop during any iteration. This indented body is executed once for each element in cities. You can name iteration variables however you like, though this example demonstrates a common pattern. The name of the list cities is the plural form of city, the name of the iteration variable. Naming lists and iteration variables in this style makes it easier for other programmers to understand the purpose of each variable. So far, the loops we've written extract information from lists. We can also use for loops to create lists and to modify lists. To create a new list, we can start with an empty list and then use the append method to add new items. This for loop iterates through each city in cities and appends it to capitalized cities. Modifying a list is a bit more involved and requires the use of a new function, range. Range is a built-in function used to create immutable sequences of numbers. It has 3 arguments which must all be integers: start, stop, and step. Start is the first number of the sequence. Stop is 1 above the last number of the sequence, and step is the difference between the numbers in the sequence. If unspecified, start defaults to 0 and step defaults to 1. Calling range with 1 integer will make that the stop argument and return a sequence of numbers from 0 to that integer minus 1. So range 4 returns 0 through 4 minus 1, which is 3. Calling range with 2 integers will make those the start and stop, and return a sequence of numbers from the first number to the second number minus 1. Range 2, 6 returns a sequence from 2 to 5. Calling range with 3 integers will return a sequence of numbers from the first to the second minus 1, separated by the third. So range 1, 10, 2 returns a sequence from 1 to 9, incremented by 2. Notice in these examples, we wrapped range in a list before printing it. This is because printing just the output of range only shows you a range object. You can view the values in the range object by converting it to a list or iterating through it in a for loop. Back in our cities example, we can use the range function to generate the indices of each value in the cities list. This lets us access the elements of the list with cities bracket index, so that we can modify the values in the cities list in place. Let's go through one iteration of this to show exactly how all these pieces work together. Len cities provides 4, so the list will be a range from 0 to 3. The index will take on each of these values one at a time. So this first iteration will have an index of 0. This part here will then index the first city, New York City, capitalize it using title, then place it back in place of the original New York City spot. This same process would then occur for each of the additional cities. We can use print to see the change in the cities list at each iteration. By getting a list of indices with the range function, we were able to index into each element of a list in a for loop to apply a change. While list modification is one application of the range function, that isn't the only thing it's useful for. You will frequently use range to repeat an action a certain number of times. For loops are an example of definite iteration, meaning that the loop's body is run a predefined number of times. A for loop over a list executes the body once for each element in the list. A for loop using the range function will execute the number of times specified by the range function. This differs from indefinite iteration, which is when a loop repeats an unknown number of times and ends when some condition is met. Consider this while loop that simulates a blackjack dealer by drawing cards from a deck list into a hand list, stopping when the value of the cards in the hand is 17 or more. This example features a new function, sum, and a new list method, pop. Sum is pretty intuitive. It returns the sum of the elements in a list. Pop is the inverse of the append method. It removes the last element from a list and returns it. You can read more about this in the official documentation. In this line, we are computing the sum of the list hand and checking if that is less than or equal to 17. In this line, we are popping the last element from card deck and appending that to the hand list. Let's talk about how this while loop works. The while keyword indicates that this is a while loop. Next is the condition. In this example, sum hand is less than or equal to 17. If this condition is true, the loop's body will be executed. Each time the loop's body runs, the condition is evaluated again. This process of checking the condition and then running the loop repeats until the expression becomes false. The indented body of the loop should modify at least one variable in the test expression. If the value of the test expression never changes, the result is an infinite loop. In this example, the loop's body appends numbers to the hand list, which increases the value of sum hand. Eventually, the value of sum hand becomes large enough that the condition becomes false. For loops iterate over every element in a sequence, and while loops iterate until their stopping condition is met. This is sufficient for most purposes, but we sometimes need more precise control over when a loop should end. In these cases, we use the break keyword. A loop will terminate immediately if it encounters a break statement. We can use this to end the loop if we detect that some condition has been met. The break keyword can be used in both for and while loops. For example, suppose you want to load a cargo ship with a list of items called manifest. This list contains tuples of items and their weights. Ideally, you would like to load all the items on the ship, but the ship has a maximum weight capacity. Therefore, when the ship's capacity is reached, you want to stop loading. To accomplish this, let's use a for loop, loading each item and keeping track of the weight of all the items we have loaded so far. Here, we check if the ship's total cargo weight reaches its maximum capacity of 100 with each addition of cargo. If it does, we use a break statement to stop loading. If not, we load the next item and add on its weight. Here's what we end up loading. That's not good. The boat is severely over its weight limit of 100. The break statement did prevent us from putting every item on the boat, but we still exceeded the limit by 111. It's difficult to see what's gone wrong. One strategy we can use is to add print statements in the code. This is a really handy technique as it can give us some insight into what happens in the code as it's running step by step. Having print statements frequently that give context can really assist us in understanding what went wrong here. Here's the loop with debugging statements added. Debugging is the process of identifying and removing errors in your code. Here, we can see that we didn't break until the weight exceeded 100, when really we should break before that item is added. Additionally, we can see that the cheeses still could have fit if the machine wasn't added. This brings us to another statement. Sometimes, rather than breaking out of the loop completely, there will be times we want to skip simply one iteration of the loop. In this case, we would use the continue keyword. In this example, we iterate through a list of foods and increment a count if the food is a fruit. Here, we terminate an iteration if the food is not found in fruit. Otherwise, we add 1 to fruit count. So when food is hummus or toast in this loop, the rest of the loop is completely skipped. Looking back at our list of cargo, notice each element is a tuple of size 2. Iterating through a list with multiple values can be pretty helpful. It's actually really easy to combine and split lists like this. If we originally started with these two separate lists, items and weights, and wanted to combine them to create a list like manifest, we can use a built-in function called zip. Zip returns an iterator, so we need to convert it to a list to see the elements, or iterate through it with a for loop if we want to print the values, similar to range. You can also unpack each tuple in a for loop like this. In addition to zipping two lists together, you can also unzip a list using an asterisk. For example, using the manifest list like this, you can separate it into an items and weights list like this. The next function we'll look at is enumerate. Many times, you'll find it useful to iterate through the values of a list along with the index. This is one way you could do it. This uses a for loop to iterate through a list of tuples containing the index and value of each item in the list. The indices are created by getting a range object from 0 to the length of items minus 1 and zipping that with the values in items. Enumerate is a special built-in function that makes this a lot simpler. Enumerate returns these tuples containing the indices and values of a list in an iterable for you. You'll be getting some practice using zip and enumerate and see how helpful they can be in the following quiz section. Congratulations on completing this lesson on control flow. You learned how to use conditional statements, loops, useful built-in functions, and list comprehensions to add more functionality to your code. Next, you'll learn how to organize your code into functions. Great job!